Have you ever looked out at your backyard and thought, this needs more lasers? Neither had I until recently. My mind began to race. I envisioned a powerful laser turret capable of hitting targets from an impressive distance. I'm talking pinpoint accuracy, glowing dots, and maybe even the ability to pop a balloon or two. It was a ridiculous idea, the kind that gets stuck in your head until you have no choice but to try and build it. The inspiration for this project came from a mixture of childhood dreams and my love for all things science fiction. I grew up watching movies with epic laser battles and futuristic weaponry. Who wouldn't want to bring a little bit of that excitement to life? So, I decided to merge my passion for building with my fascination for lasers and create a backyard project unlike any other. First things first, I needed a plan. Not just any plan, but a detailed, step-by-step roadmap that would guide me through the wild world of high-powered lasers and mechanical contraptions. I knew this project would be unlike anything I'd tackled before, so I had to be methodical. I sat down at my desk, cleared away the clutter, and let my mind wander through all the possibilities. What did I want this laser turret to do? How could I make it safe, reliable, and, let's be honest, really, really cool? I grabbed my trusty notebook and started sketching out ideas. The pages quickly filled with rough diagrams, lists of components, and wild doodles of futuristic laser turrets. I jotted down every thought that popped into my head, no matter how outlandish. Some ideas were clearly impossible, but others sparked new lines of thinking. I mapped out the basic structure, a rotating base, a sturdy frame, and of course, a mount for the laser itself. I even made a list of potential challenges, like overheating, power supply issues, and most importantly, making sure I didn't accidentally burn a hole in my wall. What kind of laser would be powerful enough? That was the million-dollar question. I needed something with enough oomph to make the project exciting, but not so much that it would be dangerous or illegal. I started researching different types of lasers, diode lasers, CO2 lasers, even fiber lasers. Each had its own strengths and weaknesses. Some were compact and easy to mount, while others required complex cooling systems or special power supplies. I weighed the pros and cons, trying to find the perfect balance between power, safety, and practicality. I dove into technical manuals and watched hours of online videos, learning everything I could about how lasers work. I discovered that even a small increase in power could make a huge difference in what the laser could do. I also learned about the different wavelengths and how they affect materials. Some lasers are great for cutting, others for engraving, and some are just for pointing at things during presentations. The more I learned, the more I realized how important it was to choose the right tool for the job. How would I build a turret mechanism? That was another puzzle to solve. I needed a system that could rotate smoothly, aim precisely, and support the weight of the laser and its components. I considered using stepper motors for precise control, and maybe even adding a joystick or remote control for manual aiming. I sketched out different gear arrangements and mounting brackets, trying to figure out the most efficient way to put everything together. I even thought about adding sensors so the turret could track targets automatically, though that might be a project for another day. I made a list of all the hardware I'd need: motors, gears, brackets, wiring, and of course the laser itself. Some parts I could salvage from old electronics, but others I'd have to buy new. I planned a trip to the local electronics store, hoping to find inspiration among the shelves of components and gadgets. There's something magical about wandering through aisles filled with possibilities, imagining how each piece could fit into my project. Where on earth do you even find a high-powered laser anyway? It's not like you can just walk into a regular store and pick one up off the shelf. I started searching through my old boxes of parts, hoping I'd squirreled away something useful from previous projects. I found a few low-powered laser pointers, but nothing that would work for this build. It was clear I'd have to look elsewhere. A quick online search led me to a variety of options, from simple laser pointers to more powerful, and potentially dangerous, laser diodes. The internet is a treasure trove for makers, but it's also a bit of a minefield. There were so many choices, each with different specs, prices, and safety warnings. I read reviews, compared datasheets, and tried to figure out which laser would give me the best performance without breaking the bank, or the law. Some of the lasers looked almost too good to be true, so I made sure to double-check the sellers and look for reputable sources. I also had to think about power requirements and safety features. Some of these lasers needed special drivers or cooling systems, and I didn't want to risk overheating anything. I made a checklist of everything I'd need to keep the project safe and functional, from heat sinks to protective enclosures. I even considered adding an emergency shutoff switch just in case things got out of hand. Safety was paramount, so I made sure to choose a laser that, while strong enough for my project, wouldn't pose a risk to myself or anyone else. I ordered a pair of high-quality safety goggles rated for the laser's wavelength, and I promised myself I'd never turn the thing on without wearing them. With my plan in place and my shopping list ready, I felt a surge of excitement. The hunt for hardware and high-powered lasers was officially underway, and I couldn't wait to see where it would lead. With my laser secured, it was time to start building the turret itself. I envisioned a sturdy base that could rotate smoothly, allowing for maximum target accuracy. Using scrap wood and some spare metal parts from my workshop, I constructed a platform with a rotating top. I mounted the laser onto this platform, carefully aligning it to ensure a straight and precise beam. Before going any further, let me emphasize, lasers are not toys. Even relatively low-powered lasers can cause eye damage. Always wear appropriate laser safety goggles when working with lasers and never point them at anyone's eyes or reflective surfaces. I made sure my workspace was well ventilated and that I had a fire extinguisher on hand, just in case. So, to assemble the turret, I used a combination of basic hand tools and, honestly, some more specialized equipment too. Screwdrivers, wrenches, and my trusty power drill were absolutely essential for putting all those mechanical parts together. And for the electrical components, I relied on my soldering iron wire strippers plus a multimeter to make sure everything was connected correctly and, actually functioning the way it was supposed to. With the turret assembled, it was finally time for the moment of truth, testing. I set up a target in my backyard, just an empty soda can at first, and then flipped the switch. The laser fired to life, sending this bright beam across the yard. I'll admit my heart was racing a bit as I made adjustments to the turret's aim, using a combination of knobs and levers I had installed for fine-tuning. The road to laser turret glory, well, it wasn't without its bumps. In fact, it was more like a winding obstacle course, filled with unexpected twists, turns, and the occasional facepalm moment. From the very first day I started tinkering in my makeshift workshop, I knew this project would test not just my technical skills, but also my patience, creativity, and sense of humor. Every step forward seemed to come with a new challenge waiting just around the corner. There were definitely moments of frustration when wires crossed and caused a fuse to blow, sending me scrambling to figure out what went wrong. Sometimes, it felt like the wires had a mind of their own, twisting and tangling themselves into impossible knots just to keep me on my toes. I'd spend hours carefully connecting each lead, only to watch a tiny puff of smoke signal that something, somewhere, had gone awry. It was a crash course in troubleshooting, and I quickly learned to keep a stash of spare fuses on hand, just in case. And then, there were the lasers themselves. Sometimes the beam would reflect in totally unexpected directions. Thank goodness for those safety goggles. I can't count how many times I had to dive for cover as a rogue beam bounced off a misaligned mirror and zipped across the room. It was like a high-stakes game of laser tag, except the only opponent was my own lack of precision. Each misfire was a reminder that even the smallest adjustment could make a huge difference in where the beam ended up. I even managed to melt a few components along the way, which was both impressive and a little bit alarming. The smell of burnt plastic became all too familiar, and I started to recognize the telltale signs of overheating before things got too out of hand. It turns out lasers are not very forgiving when it comes to mistakes in wiring or power supply. One wrong move and suddenly you're left with a puddle of what used to be a perfectly good resistor, which is honestly a testament to the power of the laser, and the importance of careful wiring. Every burnt component was a lesson in humility, and a reminder that even the most powerful tools need to be handled with respect. I started double-checking every connection, triple-checking the voltage, and making sure my workspace was as safe as possible. It wasn't just about building something cool, it was about learning how to do it the right way, even if that meant making a few mistakes along the journey. But with each mishap came a learning opportunity. Every time something went wrong, I took a step back, figured out what happened, and made a plan to fix it. I started keeping a detailed log of every experiment, every failure, and every small victory. It was like building a personal guidebook to laser turret construction, one mistake at a time. And honestly, those mistakes made the successes feel even sweeter. Slowly but surely, I refined my design and construction techniques. Each setback pushed me to get better, to think more creatively, and to never give up. In the end, all those melted wires and misaligned mirrors were just stepping stones on the path to building something truly awesome. When I first set out to build a long-range laser turret in my backyard, I honestly had no idea just how challenging and rewarding the journey would be. I started with a simple idea. Could I actually create a device that could accurately hit targets from a distance using nothing but my own two hands, some basic tools, and a lot of determination? The answer, as it turns out, was yes. After weeks of planning, sketching designs, and gathering materials, I finally managed to assemble a functioning laser turret that exceeded even my own expectations. The first time I powered it up and watched the laser beam hit a target across the yard, I was honestly stunned. It was a surreal moment, seeing something I'd only imagined in my head come to life right in front of me. Of course, the process wasn't without its fair share of setbacks. There were days when nothing seemed to work, when wires got crossed, circuits failed, and I questioned whether I'd ever get it right. I spent countless hours troubleshooting, making adjustments, and learning from every mistake. But each hiccup taught me something new, and every small victory kept me motivated to push forward. When I finally got the turret working smoothly, the sense of accomplishment was overwhelming. I couldn't wait to show it off to my friends and family. Their reactions were absolutely priceless. Some people were genuinely amazed, their jaws dropping as the laser turret locked onto targets with precision. Others just burst out laughing, partly in disbelief and partly because, let's face it, it's not every day you see a homemade laser turret in someone's backyard. The whole experience sparked so many conversations not just about the project itself, but about the possibilities of science and engineering when you're willing to experiment and take risks. We ended up having these animated discussions about how technology is evolving and how even amateur inventors can create things that seem straight out of science fiction. Some of my friends started brainstorming their own wild ideas, inspired by what they'd seen. There was a real sense of community and excitement, and it reminded me that curiosity and creativity are contagious. Of course, there were also plenty of laughs, especially when I shared some of the behind-the-scenes mishaps, like the time I accidentally triggered the safety alarm and startled the neighbor's cat. But perhaps the most important lesson I learned was about safety. Working with lasers and electronics isn't something to take lightly. I made sure to wear protective gear, double-check my wiring, and follow strict safety protocols every step of the way. I even put together a little safety demonstration for everyone before letting them near the turret just to make sure nobody got hurt. In the end, this project taught me so much, not just about engineering and problem-solving, but about perseverance, creativity, and the importance of sharing your passion with others. If you're thinking about tackling your own ambitious project, my advice is, go for it, stay safe, and don't be afraid to learn from your mistakes. You never know what you might accomplish, or whose jaws you might drop along the way.